data cleaning part. Then we were discussing about the data normalization. So today we will have more problems on the data normalization using the whatever the techniques are there. So then we had discussed about like the features need to be constructed, aggregation is there, and the generalization is there. So in that way we have discussed in the last session what is the need, how it is basically, and the more details about these three basically, the attribute feature construction, aggregation, and generalization. I had given already the examples, and we will discuss in the data warehousing part in detail about like the what is the need of like the attribute construction, how the aggregation is done, how the generalization is done while preserving the data into the data warehouse. So that will be the part we will discuss later on. Today we will cover the normalization techniques, and then we will move to the last technique of data preprocessing, that is data reduction and the data discretization. So in a way we discussed about like what is the need of normalization, and in that way in many more applications the classification algorithms are used basically, and there the requirement of the algorithm itself is like to have the data normalized on certain scale so that the execution of the application will be more faster and efficient. So in a way that we discussed. Then in last lecture we solved certain for min max normalization we covered in last lecture. So where you solved the same example with this. So min max normalization is like what, where we have from the old data set we have the values, from there we are just expected to replace the values and we are expected to get the new normalized values. Okay, so in that way it's a, we solved last time min max normalization problem. Now today you are expected to solve the z score normalization. So for z score normalization, either for in this example the range is given, basically the range is given, and based on the range we are expected to calculate first the standard deviation is used basically and mean value is used. So in that way for z score normalization, either in the problem statement itself the values of mean value and standard deviation may be given, or in the problem statement you are expected to calculate the mean values and the standard deviation. So in that way we are going to solve the problems in both the aspects today. So first of all, in this problem statement, so write down this equation for z score normalization. Its v dash is a new normalized value, v is the original value from the original data set, then the mean which is calculated on the original data set, and standard deviation is calculated on the original data set. Okay, so in a way now in this example the standard deviation mean value is given directly as 54,000 and standard deviation is given as the 16,000. Okay, so you are expected to normalize, v is given as 73,600. So you are expected to give the answer in the chart window. Yes, for the z score normalization, the equation I have already mentioned you. So it's v dash equals to v minus mean value upon standard deviation. So where 16,000 is standard deviation and v is 73,600. So answer is expected in the chart window. Yes, it's very simple. Actually, we are expected to just put in the values. Okay, so but like I'm expecting the answers from all of you. Normalization, we are expected to calculate the new transformed values actually. The third technique. So we have discussed the min max normalization, where the min max values are calculated from the original data set and new range of min max is mentioned. New min max values are mentioned in the problem statement itself. So in that way we are expected to calculate the new v dash value, that is min max normalization. And z score normalization is like where we are expected to calculate the mean value, we are expected to calculate, we will get the normalized value. Okay, so in that way the answer is 1.225 for the normalization of 73,600 value. So in that way the range of values are, so here the attribute income we are considering. Then the next example is of like the normalization using decimal scaling. So these three are the techniques. One is min max normalization, another one is z score normalization, and third one is by decimal scaling. So in a way, write down the formula equation: v dash equals to v upon 10 raised to j. So where j is the smallest integer, where j is the smallest integer from the range of the input values for that particular attribute, then in a way we should be greater than 1 basically. So in that way, now solve the problem. The example is the problem statement is the recorded values of attribute A ranges from minus 986 to plus 917. So what we are expected to have basically 917. So how many digits are there? 3 digits. So in that way j is 3 basically. J is 3. So what we are expected to have? We are expected to have like the calculation for converting minus 986 to v dash. We can have basically minus 986 upon 10 raised to 3, as j as 3 as like the range of the digits to get the value of j. So in that way the value of j is 3. So for 10 raised to j, 10 raised to 3 is 1000. So the normalization which we have done for minus 986 is minus 0.986917. So now students, tell me which techniques we are using for normalization. In chat box you are expected to type. Hello, is it clear now? Am I audible? Yes. Now is it clear, Priya? Okay, fine. So now to revise with, so we started with the transformation. So for transformation, in transformation, we are looking for the normalization. So we are normalizing the values. So for normalization, three techniques we have discussed. So those three techniques are correct. Geetanjali has given a right answer. Mean max normalization, Z-score normalization, and normalization by decimal scaling. So in a way, if you permit me, we can solve one more problem basically. So is it fine to go with one more problem? Will you solve it? Okay, so now I will show you the problem statement. Now write down the problem statement. The problem statement is, use the two methods below to normalize the following group of data. So write down the data members in the data set. So all these questions which I am discussing with you are from the university exam papers. So we will solve it only for the two data members. So the range is 200, 300, 400, 600 and 1000. Then first we will solve. Just a minute, I will share. I will share. Okay, fine. Now is it visible? Now is it visible?
Yes, ma'am.
Okay, fine. So write down the data set. So this is the data set basically, okay? And for this data set, we will first solve the mean max normalization, where the mean value is new mean. This is what? This is the new mean. New mean is 0 and new max is 1. So now for this data set, you are expected to use the mean max normalization. Okay, so this is the equation for mean max normalization. So write down this equation. So what is the mean value from the original data set? Yes, unmute your mic and tell me the answer. What is the mean value?
200. 200.
Yes, and what? Yes, yes. What is the max value?
1000.
Yes. So
1000.
go on. Yes, go on replacing the values. New max is 0 and new mean is, sorry, new mean is 0 and new max is 1. Now calculate for 300 and calculate for 1000. Okay, so calculate the values, new values for only two inputs. One is 300 and one is 1000, and tell me the answer. For 300, V is 300 and V is 1000. V is 300 and V is 1000. Unmute your mic and give me the answer. For V as 300, what will be the value V dash?
0.125.
Yes, 0.125. And for 1000, so 0.125 is the answer for the normalized values. So normalization of 300 is 0.125, correct. And for 1 now, for 1000, for 1000,
1.
yes. So what is like basically all the values are mapped, all the values are mapped in the range of like what? New min 0 to new max 1. So we are converting that whole data set. So if we observe, so this whole data set in is normalized in the range of 0 to 1, as all these are the values basically. So 200 gets converted into 0, 300 on the scale of 0.125, 400 on the scale of 0.25, then 600 on the scale of zero point 0.5, and 1000 to 1. So we have mapped all these values on the scale of 0 to 1. Is it correct? Now go for z-score normalization. Okay, so here you are expected to calculate mean value and the standard deviation. You are expected to calculate the mean value and standard deviation, and then just the replacement you have to do. So for the same 300 and 1000, I want the z-score values. Calculate the mean, calculate the standard deviation. What is the mean value?
$500.
Okay, 500. And standard deviation? Yes, what is standard deviation value? So for z-score normalization, yes guys. For z-score normalization, for this, using this formula, now calculate for 300 and 1000. So mean value, you have given the answer. Now I want the answer for like the standard deviation. So are you aware of like how to calculate standard deviation? So anyone can unmute the mic and can speak.
600.
Yes.
Ma'am, 600 is
Yes,
correct.
everybody check. Yes, everyone check with whether it's coming 600. Other students. So what the formula you have used for standard deviation calculation? Yes. Answers from others. And now replace it in the z-score formula. So it is V minus mean is 500, standard deviation 600. So V is, we are calculating for 300 value. So for 300 and for 1000. So standard deviation, just confirm with how much is the value for the standard deviation. Yes. Oh, great. Summation x mean raised to 2 upon n and then square root. Yes. Nisha, answer, your answer.
0.33 for 300.
Minus,
I think it's wrong.
no, it should be for 300, it should be minus 0.7. Huh? So here the answers are given for Z score. For 300, you are able to see the screen. Huh? So for
Yes, yes.
300, it is minus 0. For 300, it is minus 0.7. Yes. Others? Atharva 282.84. With the standard deviation, just go on calculating. Yes. So standard deviation is not 600, it is 282.842. So with 282.842, yes, the answer is minus 0.7. The answer is, so this is the answer. So yes, Aishwarya or Atharva, what formula you have used for the standard deviation? Unmute your mic and tell. Nisha, you mute your mic.
Same formula, ma'am.
Then where she was. Okay, fine. So with the same formula, the answer is this. So this is the correct answer basically. So somewhere the calculations were wrong by Nisha. So you all are expected to use this formula for standard deviation. Mean we all know, and using this formula, the answer comes as 282.84. Mean value is also calculated, and answer for 300 should be minus 0.7. And for 1000, now calculate for 1000. I'm expecting all are solving. Yes, guys, I'm expecting all.
1.767.
1.767. Yes. So it is rounded off here. Here the answer is 1.78. So it's like the rounded off. So minute difference is there. So in that way, here you can see all the answers basically on the screen for all these data members. After calculating the mean value and the standard deviation, the answers are these. So minus 1.06 for 200, then minus 0.7 is the normalized value for 300, then 1.78 is for like the normalized value for the 1000. So in that way, actually, when we do like write the program, it's very easy to convert all the values or normalize all the values using the formula, and the techniques are like the mean max normalization, z-score normalization, and the decimal scaling. So we have solved one more problem, which is the university question paper problem. So in a way, like, now we can move to the next presentation. Okay, so we will just have the review of like the data reduction techniques now, and the data discretization techniques. And then in the tomorrow's session, so tomorrow Saturday I will conduct the session, the last session will be of mine, and there we will discuss about the data reduction strategies. I will just have the review for like what is data reduction. So in a way, data reduction is like what? Compressing the data. Okay, so how the data compression, how the data reduction is done. So in that way, we are compressing the volume by using the data cube aggregation. So using the aggregation operation, so that is possible. So what is this data cube basically? So all these things are linked with the data warehouse architecture. So we are going to discuss what is it, data cube aggregation. So that we will discuss in detail in the data warehouse chapter. So for data reduction basically, so how we can reduce the data? One aspect is like the dimensionality reduction. Means what? Removing the unimportant attributes. So again, it's the responsibility of the data modeler to remove the unimportant or the redundant attributes. So that is one. Then another technique is like what? Data compression. So we can use the encoding mechanisms to reduce the data. So in that way, the data compression. So one value itself, if we are considering till one decimal point, or like what we discussed about the normalization, if we are considering, if a data is very huge and if you are scaling it on the scale of, you just understand what I am saying, if I am scaling it on the range of 0 to 1, okay, then there basically for, and if we are considering only one decimal place as 0 0.1, 0 0.2, 0 0.3, 0 0.4, then that may be the case that multiple data values for the attribute income, like the income may be basically for 0.1, the multiple income values may be like we can map. So 0.1 may be like the income value 1000, income value 1100, income value 1500. So the incomes ranging from 1000 to 1900 we can map on the scale of 0.1. So in that way, the encoding, or like what, using the normalization, we may have like the compress, we can compress the data basically. So in the original database, maybe for the income values, the values may be in, for example, the 10,000 values may be there, or like the, what are the things, for example, we are considering 10,000, but when we are compressing the data using certain encoding mechanism, then those 10,000 values may be converted into like only 1,000 values. So in that way, like for data analysis, it's allowed basically, because individual data is not important. Okay, the grouping or the data with a similar nature, the data with a similar what we can say, similar appearance is important. So in that way, you should always understand the difference between the data mining and the regular databases. Okay, so in databases, the individual data is important, but here in data mining, as we are doing the analysis on a huge data, okay, so there we are expected to group, and we have to expect the nature, or we are expected to analyze the nature of the cluster of data, or like the group of the data. So in that way, if we are compressing, if we are reducing the data, then also we get the accurate results, and the efficiency also is increased basically. So in that way, this data reduction techniques are introduced. So in that way, what we can have, we can either remove the attributes, using the dimensionality reduction, or we can compress the data. We can compress the data, that is, we can reduce the size. Then third one is the numericity reduction, where what it is basically, data is replaced by alternative smaller data representation. So in that way, using the clustering, sampling and histogram. So as I stated, the same thing basically. What we are doing, we are reducing the size of the data. We are compressing the data size. And there also the technique which is called as like the discretization and concept hierarchy generation is used basically for converting the data, or for like the reducing the data in terms of like with the particular specific range, or with going for like by removing the attributes. We can go with the replacing the ranges or higher conceptual to the higher conceptual levels using the concept hierarchy generation. So in that way, we can do the data reduction basically. So either the data reduction is possible either using removing the unimportant attributes, or encoding the data, or reducing the size of the data, or discretizing the data, or going with the concept hierarchy generation. So these 5 techniques comes under like what we are saying for like the data reduction strategies. So with this, I will conclude my session. Tomorrow we will go with various techniques in detail for data reduction, and this is like the last topic of the data pre-processing, last technique of the data pre-processing. So thank you all. We will continue this session tomorrow. Okay, thank you.